So today the topic is law of conservation of momentum. Law of conservation of momentum. It is valid on isolated system. So what is isolated system in which no mass exchange, no external force, no energy exchange. Okay, it's an isolated system and it is valid on isolated system. No isolated system, so no law of conservation of momentum. The statement of the law of conservation of momentum is that I will describe you by the diagram, by the help of diagram, that here I am having the mass 1 and here I am having the mass 2, m1 and m2. Here, before the collision and after the collision, momentum remain same. Okay, it's a statement that before the collision and after the collision momentum remains same. Here the mass 1 and mass 2, and we have named them m1 m2, and here is the velocity v1, here is the velocity v2. Now it's a collision m1 and m2. Here force, here also the force. Okay, here this force is opposite and this force is opposite to this. Okay, opposite to forces are opposite to each other. Okay, now it's a negative and it's a positive force. Okay, because they are opposite, that's why plus and minus. Okay, now after the collision, mass 1 mass 2 m1 m2. Now here is the velocity u1 u2. Okay, here the in first, before the collision, v1 v1 is greater than v2. Okay, here the v1 is greater than v2 and here the 2 u2 is also greater than u1. Okay, now the formula will be m1 v1 plus m2 u2 m2 v2 is equal to m1 u1 plus m2 u2. Okay, before the collision and after the collision momentum remains same, momentum does not change. Okay, before the collision, after the momentum remains same, or we can say that momentum remain unchanged. Okay, and it is valid on the isolated system simply.